Hello, we're going to look at troubleshooting this particular circuit. This is the band pass, or actually narrow band pass filter. And a lot of students are having some difficulty troubleshooting this sort of circuit. So I'm going to give you some hints and guidance as to how you would troubleshoot a circuit like this. So the first thing we want to do is to verify that the supply voltages are as expected. Okay. And I have a negative and positive supply with respect to ground. And on my particular prototyping board, you can see that I have a ground reference on this very bottom rail. And then I also bring it up to the top here, not the very top one, but the second one from the top. That's also my ground. It's good to have the ground on top and bottom when you're trying to troubleshoot. And the next thing I'm going to do is take my meter and measure the positive 7 to 9 volts and the negative 7 to 9 volts and just verify that they're as expected. So I'm going to need a meter. And you can see I have a meter over here. And right now my meter is measuring the positive supply and it's measuring 7.25 volts. Now notice right here, this little icon is telling me that it's measuring DC. If you mistakenly have that set to AC, you're actually going to measure 0 volts. So that's something very important to check. Okay, and right now it's actually in auto mode, and I normally prefer to not have it in auto mode because the measurements are quicker. Okay, so I'm going to take it out of auto mode and it's reading 7.25 volts on the positive. So now what I'm going to do is move my meter. So this is the red lead of my meter. This one here is the black lead of my meter. And I'm going to attach it to the rail just above that, which is my minus 9 volts. Okay, so with respect to the ground, that's minus 7 to 9 volts. And my batteries are getting a little bit low. So my meter is actually showing me 7.15 volts. But that's good enough because our amplifiers aren't outputting a very high voltage. Okay, so that's the first thing to check. And an even better way to check things, and I'll try to show you that here, is to actually come over to the IC and touch that point, pin number 7, and verify that it is 7 volts or 7 to 9 volts. And then go over to pin number 7. Okay, that's pin number 7, and just check that it is minus 7.2, or sorry, that's plus 7.25, and this one's going to be minus. Okay, we're just confirming that those two voltages are okay. And you want to do that on both ICs to make sure everything is functioning properly. The next step I would take, and that's pretty well all the DC measurements that you'd want to take. Most of the rest of the troubleshooting is done with the oscilloscope. So the first thing to notice over here is I have two scope probes. The one with the yellow wire right here, that's my channel A signal, and I'm going to have that on the top trace, which is in blue. And the other yellow wire is coming from my generator. So that's that BNC connector with red and black. Now all of the grounds are these clips here. So these are the alligator clips that are ground. This is the ground. You have to make certain that all of those go to the ground rails, top or bottom. So you see that I have that at that particular point. So one of the things that you can do when you're troubleshooting is if I have my input from my generator set to say 2 kilohertz, 200 millivolts, you want to see that you actually have that on the screen of the generator. Okay, and it seems like I do have that up there right now. So here what I wanted to point out is this is the input to my picoscope, and you'll notice too that it's important that that orange switch is set to the times 10. Okay, and I've applied that to the input of the filter. So the other thing that you might want to do when you're troubleshooting is if you notice you're not getting the plus and minus 200, you might want to isolate those two signals just to verify that you are getting the correct signals and that your circuit is not loading them. Okay, and what I mean by loading is that the circuit is affecting the measurements, so the measurements may be affecting the circuit. That shouldn't happen because our op amps have a very high input impedance, so they shouldn't be causing any problem. And the same thing with the meter, it's very high input impedance. So I'm going to bring these back to the input. So this appears to be going to pin number 3. And I'm checking to verify on my picoscope that my input signal is not attenuated. I'm outputting 2 kilohertz at 200 millivolts. Everything seems to be fine. And on the lower channel, I've set it to a very low voltage because I know it's being attenuated right now. Okay. And what you're going to notice is I can move on the right-hand side, channel B, I can move this up and down, and you want to have it so it kind of latches or holds on 0 for the red signal. And on the left-hand side, make sure that it kind of catches right at 0. Oh, that's not at 0, so just bump it up a little bit. But you have to, you'll notice kind of an extra line here that comes up. So that's important. And you'll notice I've got it triggered at 0 volts. So these are all my settings right now. Generators 200 millivolts at 2 kilohertz, 500 millivolts. And make sure, this is really important, that this is set for times 10. So all of those appear to be okay. So my next step is going to come along and make some measurements, but maybe I want to find out where the peak value is for my output. Because remember, this is a circuit that's called a narrow band filter. Okay, so we want to now adjust our input signal frequency until we can see or monitor this signal here to see when it reaches its maximum. So I'm going to be looking at the BRMS value. So it's not at these low frequencies. Okay, it's very, very low there. And if I were to go to a very high frequency, it would start coming down as well. But let's boost it up here. So we're at 800 kilohertz, 900, 1,000, still really low on my BRMS, and 2,000, 3,000, oops, it just bumped up a little bit, even more. So you notice that voltage on the lower trace is going up a little bit, 6 kilohertz. So we must be getting closer to the critical frequency, 8, 9, 10, oh, even more. Oh, what a boost, okay? That's why this is called a narrow band pass filter. We hit a certain frequency and it really boosted up that voltage. So what I'm going to do here is change the setting so that I get maybe 2 volts per division. And I'm going to change the time base because I know I'm going to bring it up a bit. So I want to make these a little wider. And now let's go up a little bit, 10 kilohertz, 20, and even more on this B voltage. Okay, because I know right now it's plus and minus 1 volt. We might even want to go up to 10. So we're about plus 1 and minus 1. So we're around, and that makes sense because positive 1 volt on the peak times 0.707 gives me around 700 millivolts RMS. So we're going to go, and we're at 20 kilohertz. And I know that my critical frequency is around 20 kilohertz. And let's go a little higher. So 10 was too low, 20's close, but we dropped down as soon as we went to 30. So I know that my frequency is somewhere in between 20 and 30. So I'm going to do a little trick here. Let's try this. I'm going to turn on something called sweep. Okay, and I'm going to sweep up. I'm going to turn the sweep on. And I'm going to sweep from 20 kilohertz to 30 kilohertz. Let's see if I can just type in 30 here or just get it to go to 30. And we're going to change by, let's say, 200 hertz. Okay, and we're going to do that every second. So let's delete that every 1 second. Okay, and what I'm going to look for is where it hits that peak. So we're at 1.25. Ooh, that looked like a peak, maybe 1.25. And where did that happen? What frequency was that? Well, we might have to go back in the loop. We're at 23. It may take a little bit of time, so I'll pause here. Okay, we're at 30 kilohertz. It's now back to 20 and the voltage is going up. So 1.2, 1.2. So it seemed to happen at about 21 kilohertz. So let's see if we can find that. So I'm actually going to type in 21 here. So I'm going to stop the sweep, go back to basic, and type in 21 kilohertz. Okay, and that gave me 1.29. And notice you don't have to go far away from that frequency for the output to drop off dramatically. So this is 20, went way down, keeps going down. And we go to 40, 50 kilohertz, drops off again. So it's at 21, it seems to hit that peak. So that's that critical frequency. We're getting 1.3 volts. Let's try 21.5. Okay, no, that's too high. So maybe 20.5. And that's too low. So 21 is right on the money. Let's go back to 21. Oops, that's way too high. 21. Okay, and that's where it hits like a peak of about 1.3 volts. So that's probably very close to our critical frequency. So with all of those measurements, we seem to have determined that the critical frequency for this narrow bandpass filter is about 21 kilohertz. And based on the components I've chosen, that all seems to make sense as well. Okay, now we're going to go back to our circuit and just point out a few things. You may notice that I have two ICs here. I've got this 741 because I'm using it as a device called a voltage follower, and it's just going to have a high impedance input, low impedance output to the rest of my circuit. So the rest of my circuit begins right here. That's the input to my bandpass filter. So what I'm going to do is leave the generator where it is, and I'm going to point out, and I'm doing this, I'm testing these points at my critical frequency. So I put the scope probe there, and I'm still getting about the same value, but it's telling me that the signals are making it to that point. And then I'm measuring right here, and that's affecting the circuit. So measuring right there, and I'm getting about the same signal. So what you want to do is move from one point to another with your scope probe, just to see if you can determine if the signal is passing through the different points. Now, the other things that you want to check are, do all of the components kind of go back to a particular node the same way they do at the circuit? So for example, here I have this side of the capacitor connected to this side of the capacitor, and I have it also connected to my 680 ohm resistor. So the 10 nanofarad, 680, and the connection to the other capacitor. And then I have this gray wire, so the other side of the capacitor is going up to the 12K resistor. And then that the same side as the 12K resistor happens to go to pin 6. So you want to confirm that. And here I have the junction between the 12K and the 680. And on this side of the 680, it's going into pin 2. And same thing on this side of the 680, it's connecting to the opposite side of the capacitor. This is my 330, 680, 680, 12. And then I have pin number 3 connected to ground, and this side of the resistor is going to ground. So you have to go through the circuit and verify that all of the components are as expected. Now let me show you how you can make a couple of measurements just to verify that the component values are correct. So let's say I wanted to check my 12K resistor. Maybe I don't know the band as I should, and I just want to check it. So what I would do here, and this is important to follow this, so I'm going to open up one side of the resistor, so it's kind of an open circuit. Or I can even move it to a spot on the proto board that's not connected to anything else. Let's try this one more time. So here I've set things up. I've got the circuit open. One side of my meter, the black wire, is going to the open side of the 680 ohm resistor. This side is going to the other side of the resistor. It doesn't have to be open, just one side does. And that's supposed to be a 680 ohm resistor. And I'm looking at it on my meter, and 0.662K, so that's very close to what we expected. Now let's just do the same thing with that 12K. I may not have measured it before, so I'm moving this over to here, one side of the resistor, and then my red lead from my meter going to the other side of the resistor. So that should be 12K. I'm just going to change my range to measure that. And if I look at my meter, it's measuring 12 kilo ohms. So everything is working out as expected. So let's do the same thing with a capacitor. So I've completely disconnected one side of the capacitor. It's not going to the 680 ohm resistor. There was a purple wire connecting it. And the other side, it didn't make any changes. So it's open on one side and left the same on the other side. And this is supposed to be a 10 nanofarad capacitor. So I'm going to change my meter to measure capacitance. And let's see what it's reading. Like I said, it's supposed to be 10 nanofarad. And I come over here and it's reading 9.4. So not bad, because these capacitors can be quite a bit off. That's why all these frequencies that I'm talking about, the critical frequencies, they might not be exactly what you expect, because the capacitors aren't that precise. So that all seems to be okay. Now notice how I have the battery connected. Let me just show you these wires. So the red lead, one red lead from one battery and a black lead from the other battery go to a center common point, and that's my ground reference. And then this wire from the left-hand battery is going to be my +9, and this black wire, right here, this black wire is my -9. And I currently have it disconnected, but let me reconnect everything. All right, we have everything hooked up again, and we're just confirming that our narrowband pass filter works okay. So I'm going under 21 kilohertz, and look at the output dropping dramatically. And then I'm going to go above 21 kilohertz, and it dropped dramatically as well. So it's operating very, very well at that precise point of 21 kilohertz. And I have to type it in here. It reaches that maximum of about 1.2 volts. Okay, with the input being about 140 millivolts, because that's 200 millivolts peak. So, well, just a bit under, but 200 millivolts times 0.707 gives us about 141. So it's behaving the way we would expect. Okay, now the other thing to notice here is that I have taken some time and trouble, but I'm going to save a lot of time, because it maybe took me half an hour to build this circuit, to find the components, put in the capacitors, the ICs. But once you've got it built for one circuit, we're just doing the same thing for 3. So it's just a matter of changing the components around. But notice I use different colors, and that's really important in helping to troubleshoot. I've got yellow as my input signals, orange for my output. I've got wires interconnecting that are white, gray, and purple. And I only ever use red for the positive voltages, only ever use blue for the negative voltages, and black wires, anywhere I see a black wire, that's equal to 0 volts. Okay, so you want to test and troubleshoot and verify that everything is working as expected. Hope this short video helps you out. You can watch it a second time if you want, and look at maybe where you're running into some difficulty with your circuit. But take some time, wire it neatly. You will get it done. It will work as expected. You need to know what the critical frequency is for your circuit. You need to know what a low pass filter does, what a high pass filter does, what a band pass filter does. Know the shape of the expected output as you pass through low frequencies to high frequencies. Thank you.